Okay, thank you. Thank you all for staying here at this time of the day. I'm the last one, so I will try to not to take too much time. I'm Jordi Portell. Most of you know me already. I'm the Deputy Technical Director of the ICCUB, and mainly on the software part from the Technological Unit. I think it's the first talk that I give with mask, and it's exhausting. But anyway, no, it's okay. I will try to do my best. Good. So I will explain you the several projects that we are working on regarding related to software or computing activities. Mainly, they are mostly or most of the efforts are on Gaia and now also growing on Virgo, as you will see. But we have quite a few other interesting projects. Starting with Gaia, this thing that most of you already know. Most of the software and computing work that we're doing for Gaia is within the frame of the Data Processing and Analysis Consortium of Gaia. It's DPAC. Most of you already know this, so I will try not to spend too much time on this, but we have quite a few interesting activities. The most active ones, which very significantly contribute to this success of the several data releases, is within the frame of the core processing unit or coordination unit 3, and more specifically on the intermediate data updating system, IDU. In the system, which is running in Mare Nostrum, I will go into this now, our team, quite a small team I have to say, is working especially on the integration and tests of algorithms, including several instrumental calibrations of the PSF or LSF, the line spread function, image parameters determination, now also detection of images. Then development of new algorithms for the attitude and calibration bootstrap to start up the process without degeneracies or dependencies on other data reduction systems. Spurious detections classification, like for example in this image field here that you can see several real stars in blue and then some spurious detections which were successfully found by this algorithm, and they were masked out to avoid polluting the catalog. Then on the cross-matching, here we are very active and very experts, I have to say. And more recently, within the frame of an industrial contract with the European Space Agency, we have worked and are continuing working now on the resolution, on-ground detection and resolution of close source pairs. Like for example in this one, this is a very beautiful and trivial case of two quite nearby sources or close sources which were not previously resolved in, for example, in DR3 and in the forthcoming DR4 catalog in a few years from now, as I will mention later. They will be resolved and furthermore with nice astrometric parameters with proper motions, parallaxes, and so on. So this is the kind of things that we do on algorithms, software implementations, and execution of all of these. This will be very interesting for dense areas, by the way, in clusters and so on. So some guy down there at the back may be very happy with DR4. Pity that it will be in a few years from now, but that's life. Another point where we are very active is on DPCV, this data processing center in Barcelona. As I said, it's in the Barcelona Supercomputing Center in BSC, in the Mare Nostrum supercomputer. Here we are finishing now the second execution of the image parameters determination and instrumental calibration and so on, processing these 5 years and a half of full nominal emission for the first time, with 65 terabytes output twice, now that we have the second processing, millions of CPU hours, 142 billion observations, each with 10 small images in it, so it's quite amazing. And this is for, as I said, for the preparation of the fourth data release of Gaia. Additionally, this is the official backup of the full main database of DPAC, and also of the raw telemetry archive. So quite an important piece or quite an important element in Gaia, and we are acknowledged because of that. We also work on data visualization tools like the ones that generated this kind of plots, and also supporting. In the past, we designed and implemented this initial data treatment system, the one receiving every day the data, the raw data from the satellite, and processing that, generating the first intermediate data to do health checks of the satellite and get an initial reduction. And now we are just providing some support on the monitoring and resolution of issues that may happen. Other things quite very important these days, actually, for this preparation of DR3, which will take place. Yeah, I will announce the date soon. That's already known, by the way. The CO9, the ninth coordination unit, which is for the catalog preparation, with one of the coordinators sitting here in the room as well. It works very intensively these days for the catalog validation of EDR3. Couple of years ago, no, 1 year ago, if I recall right. And then now for June, as I will tell later, for DR3, for the third data release of Gaia, which will include many new data types, complex data types with multidimensional objects and so on, many tables, parameters, and so on. And then it requires a development of many software tools for the generation of exhaustive statistics, systematic statistics covering all of the sources, all of the parameters, so that we don't forget anything. And despite of that, there's always some subtle effect that passes through the validation, but that's fortunately minor things. Additionally, we also work, I personally work on the project office, supporting some technical interfaces between several units and centers of DPAC, providing technical support, doing estimations of the database sizes and the transfer sizes, curating the operational events, things that happen on board or on ground or in the downlink, developing or providing support to some tools to manage them and to visualize them, providing support to additional, typically cross-unit validation of DPAC, and yeah, things like that. So this would be the core of our work, and especially on Gaia. But still within Gaia, there are several additional activities, very interesting ones, which are ramping up, I have to say. One is something more or less recent. One of these days, actually it should have started 1 year ago, but bureaucracy is terrible, you know. This is so-called OCRE, or the Open Cloud Research, European Research for, yeah, whatever, I don't remember the acronym, but this is some European initiative granting computing time and storage and services from commercial cloud services. And these, we were granted these services from Europe, and we will be able to do research on Gaia data. Initially, we were just thinking of EDR3 data, but now, thanks to this delay in the project, we will be able to also use DR3 data. So we will have several nice technologies, a Spark cluster, data lake, all this fancy terminology that you have heard recently. Running large simulations, getting richer statistics, and in general taking advantage of these more or less massive and modern cloud services on these science data. More or less related, GDAF, this Gaia Data Analysis Framework, it is inherited from another European project. It was called Genius, where our group developed some big data-based big data framework, or a framework based on big data technologies, like these Hadoop, Parquet libraries, interfaces, notebooks, things like that. And this also allows to run massive queries or massive data mining on Gaia data. It was formally deployed at CESCA, or later called ICCUB, and now we are migrating this to the BSC to get more computing power and storage capacity. And finally, related to Gaia, we have this Gambons Plus, I like to say, this Gaia for Sustainability project, something that we were granted from the Spanish ministry, a proof of concept project, which basically aims at reusing or extending some project that was born here in-house, I think, which starts from the Gaia catalog, from the photometric information of the Gaia catalog, and uses this to estimate the light pollution in your area by comparing that against the reference background that you should expect from the natural sky. So very interesting project. And here we will, in this case, we will continue this during the coming 2 years, if I recall right, improving the software, the already available software, using modern web technologies, GPU computing, and so on. And to finish with Gaia, this is just an appetizer or a reminder of the numbers that you will face on June the 13th, when DR3 will be made public. We are talking about, besides these 1.5 billion positions, velocities, parallaxes, and so on, that you already have from EDR3, we will have around 33 million radial velocities, at least 100 million BP and RP spectra, at least 1 million RBS spectra. Quite an amazing data set, you will see. And looking at the future, DR4 is expected around 25-ish, more or less, with APOC data for all data products and sources, so it will be a huge data set. And DR5, which will include data from the extended mission that is taking place now, hopefully until 24, 25, when the full onboard will run out. And the date is TBD, but we are already working on that. Good, okay, the next big or more active project on the software side is Virgo. And actually I have to say that the ICCUB Virgo participation was kind of triggered from the technology unit, or motivated from the technology unit, and I'm really pleased to see that scientists have taken the train and working a lot on this exciting project. So we started with this idea of providing some contributions on computing, instrumentation, and so on. On instrumentation, I have to say that in principle we have concluded for now. There are no further activities envisaged, who knows in the future. On computing, we had some kind of impasse without providing much contributions there, but now thanks to a full FT, we are providing again quite some nice contributions since last December. But especially on data analysis, science modeling, and exploitation activities, it's, as I said, I'm really pleased to see that. It's growing a lot. Excellent experts have joined the Institute and are working on these data analysis activities. For example, one of the things that I know more, because it's my PhD student, it's the denoising plugin, some algorithm based on this. Well, I don't remember the acronym. It's the name of the initials of some authors. But it is basically, you cannot see this very well, it is basically a denoising algorithm which was envisaged initially for image denoising, but with some adjustments we have been able to apply this to gravitational wave strain data and achieve, maybe on the online slides you will see this a bit better, we decrease a bit the overall noise in this spectrogram. This is the gravitational wave signal, the in spiral, the chirp, the ring down, and so on. And this is cleaner and at all frequencies, which is more important, thanks to this denoising algorithm, increasing the signal to noise ratio. And we expect to activate these for the forthcoming data taking period, starting December this year, more or less. So yeah, this is one thing. Then on data analysis, people here are working on better templates or more templates for high eccentricity, compact binary objects, even hyperbolic encounters, precision, including gravitational lensing effects, so things like this, and providing even a richer bank of GW templates to make this fitting, these model-based searches. By the way, this work here is focused on an unmodeled search approach, so not requiring any template. And then, yes, also working on new pipelines and improved interfaces or improved implementations of these bank, pipeline usage of the bank, and so on. And on computing, as I said, we have a new guy from India working on Virgo now. He's for now working on a federated authentication service, which was giving some headaches to the collaborations. And soon we'll start working on optimizing or improving the continuous wave search pipeline, providing support to scientists as needed, as necessary, and implementing some centralized monitoring of massive data handling system and high throughput computing job management for the several computing centers. Beyond Virgo, we are also starting to work on other gravitational wave projects. One of them is LISA, that Eduardo mentioned before. It's this, actually, today I checked the launch date. It looks like 37, more or less, to be confirmed. Will be delayed, for sure. And it's quite amazing with these 2.5 million kilometer arms, these formation flying 3 satellites, and the ICCUB contributions on the software or computing side are still to be defined, but in principle we aim at contributing on some data challenges on the data analysis case. And I jumped this. This is the Einstein telescope. It's a new concept of gravitational waves observatory underground, with some cryogenic elements, with 10-kilometer arms instead of the 3 kilometers of Virgo or 4 of LIGO. I didn't talk of LIGO, by the way. And now it is part of this European framework research infrastructures roadmap, whatever. And the envisaging contributions from the ICCUB is on the science case and data analysis, on data processing pipelines, outreach, and on this so-called e-infrastructure board, which is on computing and software in general, defining the overall architecture and the way to manage the huge amounts of data that the observatory will generate. So that's mostly it, but besides this, we're starting to work on some other projects, like mainly Plateau. We expect to have one person working on this, mainly working on the ground-based observation program. Plateau is an European Space Agency mission, expected to be launched in 2026, with the goal of finding and characterizing new exoplanets with the photometric transit approach. And the work that we aim at is on defining the architecture and the overall system that will receive the candidates from Plateau, from the mission, and schedule or plan the ground-based observations of these candidates to confirm or reject and finally characterize these new exoplanets. And yeah, as I said, we are ramping up this now. Another project that Chema explained very well before is on nanosatellites. This is this platform that we have been working on for the last 2 years. And remarkably, on the software side, we have worked already on some packetization approach, some implementation, some error detection and correction algorithms, and especially on data compression to be very efficient on board. And finally, on other projects, we are also working since some years, actually, on Gaia Near, hopefully the successor of Gaia on the near infrared side. This is a long shot. We envisage a launch around 2040, more or less. aiming at some onboard data handling, on-ground raw data processing, the kind of things that we have already done for Gaia. On Euclid, this is much shorter. It will be launched in 24, 25 maybe. No, 24 I think. And the specific engineering tasks are still being defined, so it's a bit more difficult to find our place there, since it's very well advanced. Jasmine, which is a Japanese mission, a kind of mini Gaia, trying to do some astrometry and also some photometry on a single band. We aim perhaps at supporting some PSF models where we are kind of experts. And finally, on some future activities that will be funded by these Fondos de Recuperación Europeos, these European funds that hopefully will arrive soon. We aim at working on some fusion of Gaia data, of the Gaia catalog with other catalogs. For example, one interesting thing would be what Gemma Busquet has mentioned before, fusioning Gaia with VLA data, and also providing some transversal support to other projects of the Institute. And that's basically it. Just a summary of what I have explained, and that's it, in case you have questions. Thank you.
Thank you, Jordi. So there is time for a few questions.
Thanks for the nice summary. This slide with the number of CPUs you need to process all the Gaia data caught a bit my attention. I mean, I'm no expert on this data, but I assume there are many processes that you need to apply that are highly parallelizable. So I'm wondering if you apply any kind of parallel computing techniques, or you have considered other architectures rather than millions of CPUs to do this.
That's a good question. GPUs have been on the table for years now, but in Gaia we have a small, tiny, negligible problem. Java. Deepak is 99% implemented in Java. And the good and efficient deployment or virtual machine of Java for GPUs doesn't exist yet, and I wonder if it will ever exist. So that's there are some people in Geneva investigating that with promising results, but so far we are very lucky that VSC has always bet for x86 standard architecture, and that's really wonderful, because perhaps this is not by far, this is not the most powerful supercomputer in the world, but it is one of the easiest to use one, and it's really wonderful. Yeah, in this case, Gaia and Deepak is basically a massively parallelizable problem, or better said, on distributed computing, because we chunk the data to be processed in small pieces and throw that to the processors.
There's one more question. No, if not, let's thank Jordi again. Thanks a lot. Thanks a lot to the people representing the technological part of the institute, which is a very important one. And I'm sorry that, well, it's the last session. It's usually the case in the winter meeting that it's the last session, but perhaps in this year there was a more substantial decrease than usual in the amount of people attending to these talks. Still, I want to thank you all, and also those who are not here but were before, because I think in general, despite the COVID situation, the attendance was quite good. Similar or even better than previous years when it was taking place in the Eduard Fontserè. So I'm, well, as a, let's say, kind of main organizer or whatever, I'm very happy that it went this way despite the situation. So thank you again, and hopefully next year we probably will meet again here, but with coffee breaks. So we'll be better. Thank you.